Hello everyone. In this lecture, we are going to discuss about activity networks, which is a technique or method to find out or establish the different relationships between various activities in a construction project or any other project. So let's first look at a list of activities. So these are various activities starting from A to G. So these activities may be earthwork, then footing construction, then column construction, then brickwork, then plastering, etc. So these activities will be dependent on the previous activities and so on. So in the traditional bar diagram method, we can draw the bar diagram like this, where this length of this bar diagram shows the duration of each project. So at first we'll have the activity A starting at the first day. After that B will start, and here you can see that B starts where A ends, that means on the third day. Then comes C, but C can also be started when A is completed. So C can also start on the same day as B, because it is not dependent on B, but it is only dependent on A. So as we have completed A, we can start both B and C. After that, the activity D will start, and here we have written predecessor activities. That means D is dependent on B and C. Only when B and C are completed, we can start the activity D. Therefore, D will start here, and it is taking suppose 2 days only. But one thing we can see that it will not be able to start D at this point when the activity B is completed, because it is also dependent on C. So when both B and C are completed, which is on this day, then only we can start the activity D. After that, activity E is there, which is dependent on C, and C ends here, and therefore we can start the activity E from that point onwards. After that, activity F will start. Again, F is dependent on D, so we'll see where D is ending. It is ending right here. So after D is complete, we'll start the activity F. And after that, activity G, it is dependent on E, and therefore we'll have to look where E is ending, which is at this point. So after that, we can start the activity G. And these are the last activities. There are no other activities after that. But the problem is, as we have discussed in our previous lectures, that this kind of a method or bar diagram method is not really helpful in understanding the relationships or interdependencies of activities, because we can do it by showing this kind of arrows like this, then, but it's not very helpful to understand in this kind of a diagram. So we have a different way of representing these activities and their relationships. So that's by drawing a network of activities. So for example, at the beginning, we'll start with a node which represents the first day. So from this, we'll start activity A. When activity A is completed, then we can go for activity B and C, which both of them can be started after completion of A. So suppose this is activity B and this is activity C. After that, D can be started after both B and C are completed. So this point represents ending of C, and this node represents ending of B. So after that, we'll start the activity D, and activity E starts when C ends, and that will be this point. So this is activity E, and after that activity F will start after D is completed, so here, and G will start when activity E completes, so this will be F and this will be G, and this represents the end of the project. Now here I have not mentioned exactly what kind of logic or what kind of technique I am following, so we'll get into that in the next slides. So an activity network, there are two different methods for drawing these activity networks. First one is what I've already demonstrated, so that's activity on arrows. Here an activity is depicted by an arrow joining two nodes. So suppose we have two activities, activity A and activity B. Maybe this is earthwork and this is footing construction. So the node represents starting or ending of an activity. That means this node 1 represents beginning of earthwork and the node 2 represents ending of earthwork, but the node 2 also represents therefore starting or beginning of activity B, which may be construction of footings, and the node 3 represents ending of this activity, activity B, and so on. So only thing to remember here is that the activity is represented by the arrow and the nodes represents the events, which is either beginning or ending of one or more activities. The other method or the other technique is activity on nodes, and it's different because here an activity is depicted by a node instead of an arrow. So we'll have two activities which are represented by these two nodes A and B, and they are simply joined by an arrow just to show their dependency, that B is started after A is completed. So this is the basic difference between these two methods. Now so we'll have some example of this kind of an activity chart or a project where there are 4 activities, out of which A and B are independent. That means they can be started at the beginning itself, both independent of each other. Then activity C starts when activity A is completed, and activity B will start when activity B is completed. So we'll try to do both of them in try to do this network in both methods. So in activity of arrow method, we'll start with the first activity, which is activity A, and it starts from node 1. Node 1 represents beginning of the entire project, but at the same time we can also start B. So B will also start from the same node 1 like this, and after A is completed we can start activity C, which is dependent on activity A like this, and activity D can be started once we completed activity B, which is represented by ending of activity B is represented by the node 3, and from node 3 we'll start activity D. And since activity C and D are the last activities, that means they are not predecessors to any other activities. That means there are no other activities after C and D. So we can represent the end of the entire project by joining both these activities to a last node, node 4 in this case. So this is how we draw the activity network on using activity on arrow method. Now let's try to do the same in activity on node method. So in this method we'll start with two activities A and B, which are not dependent on each other and they can be started at the beginning itself. So activity A and activity B will be started. Now activity C will depend on activity A again, but before that, since it's not clear which starts first, so in this method we generally use an extra node at the beginning which represents the start. It's not an activity, but it is used just to show that it is the starting point, and from that these two activities, it may be one activity, two activity, or even more activities parallelly at the beginning. So all the activities starting from the first start node are the first activities. After that, we'll go for activity C, which is dependent on activity A, and it is shown by just by drawing an arrow from A to C. And then the next activity, activity D, is linked to activity B, and that is again shown by an arrow from B to D. Now these are again the last activities, so there is no other activity after that, so we can simply show the ending of the whole project by joining these two nodes to a last node which represents the end of the project. So this is how these two methods are used to draw the activity network. So things to remember here are that the node represents an event, that is beginning or ending of activity, and the arrow represents the activity in case of AOA or activity on arrow method, and in the other case the node represents the activity instead of the arrow, and the arrow represents only the logical dependency or sequence of the activity rather than the activity itself. Now let's try to do some more examples. So we'll try these three examples, and I'll switch to a different screen now. So this is the first example here, which is we have a first activity A, which is not dependent on anything else. So let's first do it activity on arrow method. Here we'll start with the first node. We can number the nodes, that is number 1, and from that one single activity will come out, which is activity A. After A is completed, we'll show the ending of activity A by second node, node 2 suppose. Then here we can see two activities B and C are dependent on activity A, and therefore after A is completed we can start two more activities B and C. So this is activity B and this is activity C. After B is completed and C is completed, we can carry on to the next activity, which is the last activity in this table, and that is activity D. Now here is a problem. From where do we draw this activity D? Do we draw it from here or we draw it from here? So in that case we use something called a dummy activity, which is generally shown by a dotted arrow like this, and then we'll draw this activity D, which represents the ending of the project, and we can also number these nodes, node 3, 4, 5, etc. So a dummy activity in this case is not a real activity, but it is just used to show the dependency of a certain activity. That means, as we can see, this node 4, after which we can start activity D, is dependent on completion of both activity B and C, and therefore we are drawing an extra line or extra activity just to show the dependency of D on both B and C, because we cannot draw a single arrow from two nodes, and therefore we are using this kind of a dummy activity. It's not necessary that you draw it from this particular node, you can also draw it from this node. So in that case, what we have to do is we have to show this dummy activity in the other direction, and now this is the activity D, and this both of these diagrams will mean the same thing. That means activity D is dependent on B as well as activity C. So this is how an activity network can be drawn using activity on arrow method or AOA method. Now let's try to draw the same activity network using activity on nodes method, and that we can do by, we'll always use the start node at the beginning, and from that, now in this case only one activity is there which is not dependent on any other activity, and that is activity A. So this is activity A. After activity A, two more activities can be started, B and C, activity B and activity C. And the dependency of activity B and C on the activity A can be simply shown by drawing these two arrows. After that, the final activity D will depend on activity B and C both. Therefore, if we draw activity D using this node, then we can simply show the dependency of activity D on both B and C by again drawing two arrows starting from B and C and meeting at activity D. Now the difference here, as you can see, is that in activity on node method, dummy activity is not needed. Dummy activity is needed only in case of this activity on arrow method. So that's one thing to remember. So let's now go to a second example, which is this one. So now we have 5 activities where first 2 activities can start at the beginning. So let's first try again activity on arrow method. In this method, we'll start both activities A and B, activity A and activity B, starting from the first node. Then activity C depends on A and B depends on D. So once A is completed, we can start activity C, and when B is completed, we can start D. After that, activity E can be started, which is dependent on both C and D. So C has completed and D is also complete. Now we can start activity E. Now here, let's see if this is needed. Now we can again show some dummy activity from here to here and then start activity E, and that will represent the end of the project. But if you look at this particular diagram, you can see that this dummy activity is not actually needed. That means instead of drawing it like this, we can simply point both of these activities to a single node. This is C, this is D, and then start activity E. The logic is still valid here because activity C is again shown to be dependent on A, activity D is shown to be dependent on B, and activity E is shown to be dependent on both completion of both C and D. So now you see, in this case the dummy activity is not needed. So why was it needed in the first place in the previous example? And that's because both these activities, here this dummy activities was used because both these activities B and C started from a single node, and therefore they could not lead to a single node. That means if, let's try to show it in a different way. So if this is the node 2, that means this node, then activity B will start here and activity C will start here, and they cannot be shown to leading to a single node, and this is something which is a wrong step in the drawing process. Two activities cannot have the same beginning and same end, and therefore these two activities B and C had the same beginning, and therefore they cannot have the same ending, and therefore this can never be done. But in the next case, we have again two activities C and D on which this activity depends, but they have two different beginning points, and therefore they could have a common ending. So one thing we can conclude from here is that two activities can have same beginning, or two activities can have same ending, but they cannot have both. That is, they cannot have the same ending, same beginning and same ending. That will be wrong. They can only have one of them. So now let's try to do the same problem, same diagram in activity on node method. So I'll just keep this a little bit smaller. And if we try to do it again in activity on node method, then we'll start with the two activities A and B. So A and B, and they will be linked to the start node, and after that we have activities C and D, C and D, and their dependency is again shown by these arrows. Again, remember, these arrows are not showing the activities but only the link between activities, because the activity is shown by the node itself, unlike this method. So after C and D are completed, we can go for activity E, and its dependency can be shown by again drawing two arrows from C and D, because it is dependent on C and D. After that, it is nice to draw this end node or finish node, just to show that the project is completed. So I guess you have some idea about this, how these networks are drawn. Now let's go to a little bit complicated problem having more number of activities. Now it has 7 activities. So again, let's start from activity on arrow method. So we'll start with activity A and B. A and B from the first node. Here the node is not representing activity, it is only representing the beginning of the activity, and the nodes will also show the ending of different activities. After that, activity C starts. So C is dependent on both A and B. Now C will be starting, it can either start from here or here. Now we have to use a dummy activity just to show the dependency of this activity on both of these previous activities A and B. So how do we do that? We'll use a dummy activity like this. You can show the arrow on either side, either to this side or to this side, it doesn't matter. Excuse me. Yeah. So activities C can start here, and in that case we'll have to show the arrow like this, and this is not a real activity, it is only the dummy activity. So when this C starts, then we can also now go for the activity D, which is dependent on activity A. Now we have a problem. We can start activity D from this node because this node represents end of activity A, but the problem is that we have linked this to activity B also using this dummy activity, and that causes a problem because if we start the activity D from here, it would mean that D is dependent on both A and B because it is starting from this node, suppose node 2, which represents completion of activity A and B, and therefore we may have to revise this whole network. So what can we do now? We can try another route where we'll link the dummy activity the other way, that means from A to B. So if we start the activity C here, then we can start activity D separately here. Now the logic is not violated here because C is shown to be dependent on B and A because two arrows are meeting at this node 3. This node 3 represents completion of both A and B. So now will it be okay? Let's check. So we have completed activity C here and we have completed activity D here. Now we'll move on to activity E, but again there is a problem. Activity E is again dependent on activity B. So from activity B, if we start E, now you see the diagram would look like that E is also dependent on B and A because the node 3 from which E is starting represents, or node 3 represents completion of two activities because two arrows, this one and this one, are meeting at activity at node 3, which means node 3 represents completion of both A and B, and that would mean that E is also dependent on activities A and B, but according to the table E is only dependent on B. So this diagram will be misleading and wrong actually. So what can we do? Now we have to go for a little bit more complicated diagram because now we have seen that there are activities which are dependent on A and B alone, like this. So activities D and E are dependent on A only and B only, but there is another activity C which is dependent on both A and B. So we'll need 3 different nodes to start these 3 activities from, but we have only 2 nodes here, activity node 2 and node 3. So what we can do is we can add another node here, a dummy node, which will be connected by dummy activities, like this. So there are 2 dummy activities here, which leads to a 4th node, node number 4. Now this node represents, as you can see, 2 arrows are meeting at node 4. Now where did those 2 arrows come from? One came from completion of activity A and another came from completion of activity B. So this is the node from which we can start our activity C. Now this node, node number 2, it only now shows completion of activity A, because only one arrow is meeting at this node 2. So from that node, node number 2, we can start our activity D. So from here we'll start D, and from this node, node number 3, we'll start activity E. Now the logical sequence or the interdependency is not misrepresented by the diagram. That means E is starting from completion of activity B, D is starting from after completion of activity A, and C is starting after completion of both activities A and activity B. So that's how we have to do some trial and error method to find out the final activity network. Now after that, if there is anything left? Yes, activity F. Activity F is dependent on activity C. So after C is completed, we can start activity F, and activity G can be started after F is completed. So if F is complete here, then we can start activity G. And that's the end of this activity network, but there are these loose ends here. That means activity D and activity E, where will they meet? They will meet the end node, because D and E are not successors to not predecessors to any other activity. That means there are no successors to D and E, or there are no other activities which are dependent on D and E. That means along their own paths, they are the last activities. So what we can do is we can simply connect D and E to the final node, which will be node number 7. So this is the entire network that we can draw. So this is how we draw the activity network for using activity on arrow method. Now let's try to do the same using activity on node method. We're using the same activity chart. All the dependencies are same, there are the same number of activities. So let's try the other method. Again, we'll start from the start node or begin node. Then we'll have these 2 activities A and B, A and B. After that, activity C is dependent on both A and B. So if we draw activity C here, it will be dependent on B and A and B. Then activity D will depend on activity A. So we'll draw D here, and activity E, which is dependent only on B, you can draw it separately here, like this. Now see, in this method, all those complications are not exactly present. All the requirement of dummy activities and all those things, because it's much easier. Therefore, after that, activity F is dependent on C. So this is activity F, and after that, the final activity G is dependent on F, and that's it. Now, unlike the previous method where we joined all the last activities, that means activities which are not succeeded by any further activities, that means activities D, E and G. If you notice, these activities are not predecessors to any other activity. That means on the predecessor column, you will not find these activities D, G and E. So here D, G and E are not present. That means they are not exactly governing the beginning of any further activities. They are the last activities along their own paths. So therefore, we'll have to represent that fact in some way, and we'll do that in this case by joining all these activities to a final node, the end node or the finish node. So this is how we draw the activity network in activity on node method. So I guess you can now try different activity networks based on some hypothetical problems where you just make up some number of activities and put some predecessor activities for all these and try to draw this kind of activity networks on using both these methods. So we have solved these three examples. Now, a few points to remember are that activity with no predecessor activity start from the first node. That means if you have a table where suppose this is the activity and this is the predecessor activity list and this is the activity list. So suppose we have A, B, C and so on. So the activities which have no predecessor activities here, suppose A and B are not having any predecessor activities, so they will be starting from the first node. And if activity C is having some predecessor activity, suppose activity A or B or anything, so in that case C will not start from the first node. And activity with no successor activities, that means activities which are not present on this column, which are not predecessors to any other activities, which means the same thing, they do not have any successor activities, so they will meet at the last node. So all these activities will be meeting at the last node, and all the activities which have no predecessor activities, they will begin from the first node, like this. Then comes two or more arrows can have a common beginning. I think we have already discussed in the first few slides. That means an arrow can be, or two or more arrows can have the same beginning, or they can have the same ending, but they cannot have the same ending and beginning at the same time. So this is wrong. There must be some other nodes in between. So if you find in your activity diagram that two arrows are starting from the same nodes and ending on same nodes, then you may you consider that as a mistake and revise the whole diagram. Then comes, there are no dummy activities in arrow on nodes method, as we have already demonstrated. So these are the necessary points that you must abide by, but there are some other points which are just to help you in drawing these activity networks. That is, so just like any kind of drawing, draw a trial network at first where you can use as many nodes and dummy activities as you want. So sometimes you may use 2 or 3 dummy activities like this, but later on suppose you find out that 2 activities were not needed, and we can use, so if we use suppose this kind of a 2 activities were there and we used an extra node and 2 dummy activities to start the next activity, but sometimes at the end you may find out that it was not needed and you can simply do away with 1 dummy activity like this and no extra nodes, so you can start the activity here. That is true only in case of activity on arrow method. Then try to reduce the number of nodes and dummy activities in the final diagram. So if you find that some nodes and some arrows, some dummy activities are not needed, you can reduce their number. For very complicated networks, this is only my personal opinion, that you should go for activity on nodes method, because then you will be avoiding all this requirement of dummy activities and dummy nodes. Then it is advisable to avoid intersecting arrows, but intersecting arrows means it's generally found in activity on node method. Suppose you have one activity here, one activity here, one activity here, and like this. So this activity is suppose dependent on all these 3 activities, so we'll have to draw arrows like this. Now this activity is dependent on this activity as well as this activity, so in that case we'll have to draw 2 arrows, and in this case these arrows are intersecting at this point, so it's unavoidable in this situation, so it's actually okay. Don't think that it is a mistake if the arrows are intersecting, but if you can, try to avoid this kind of intersecting arrows. For example, if suppose this activity is dependent on this particular activity, then you can draw an arrow like this. Suppose this is activity A, B and C, and these are D and E. So if activity E is dependent on B, so we can avoid this intersection just by shifting B from here to here. So this is activity B, this is activity C, so these still dependent on both all these 3 activities A, B and C, but now instead of drawing this kind of an intersecting arrow, we can simply draw a arrow separately from B just by switching their positions. So these kind of adjustments can be made after you complete your diagram and draw a separate final diagram, final network diagram. So I'll leave some example or exercise problems for you in Google Classroom to practice. So that's all for this lecture. Thank you.